Okay, welcome to Lesson 5 of Module 4. Title of this lesson is Writing and Solving Linear Equations. Of course, we've been solving linear equations, and in some earlier lessons we practiced writing expressions and even writing equations. So we'll do some examples together, and most of these examples are from geometry, so that's kind of fun. So remember, we are going to be using the properties of equality when we go to solve these equations. And the properties of equality just give us ways to transform equations into the form x equals some number. So we get x all by itself on one side of the equal sign, and all of the non-variable terms onto the other side of the equal sign. And we do that by using the properties of equality. So the first one says if A equals B, so we're going to assume A equals B to be true, then A plus C will equal B plus C. So if I add the same number to both sides of an equation, I had A and B previously, I add C to them, then that's also going to be true. And it will be an equation with the same solution as the original equation. So we can do that for addition, subtraction, multiplication, or division. So these are important properties, and we will be using them a lot. Okay, so let's look at the first example. Example 1 says one angle is 5 less than 3 times the size of another angle. Together, they have a sum of 143. What are the sizes of each angle? Okay, so with a problem like this, there's some different ways you could go about it. You could, a diagram would be good. I draw an angle here that is 143 degrees, and so I probably want to make it a little bigger than that. That looks almost like 90. 143 degrees is going to be almost, well, just shy of a straight angle. So let's do that. There, and come up like that. That's closer to 143 degrees. Okay, so I'm going to have two angles. So somewhere in here, let's get a different color. Okay, so I'm going to have an angle here and another angle here. So there's two angles adding up to 143 degrees together. I need to find the sizes for each angle, and I know this piece of information, that one of the angles is 5 less than 3 times the size of another angle. So why don't you just try some problem solving techniques and see what you could do with that. So if you want to pause the video, that would be good, so you can think about it and see if you can come up with something that works for the sizes of both of these angles. Okay, so you could just start guessing. What if I guessed that this smaller angle was 20 degrees? Well, if that one's 20, 5 less than 3 times, so 3 times 20 is 60, minus 5 would be 55. That would make this angle 55 degrees. And together they're too small, because together they're only 75. So I go back to the drawing board, right? What if this angle is 40? You know, and if we were in class, I would be getting your ideas here. Well, 3 times 40 is 120, And 5 less than that would be 115. So 115 right here, that's too big. So 40 is too big, 20 is too small. Let's try 30. See if we can get closer. Curious to know if any of you got closer by doing this guessing. So if my smaller one is 30, 30 times 3 is 90. Minus 5 would be 85. So this angle would be 85 degrees. You see what I'm doing? I'm just guessing for the first angle, and then I'm taking 5 less than 3 times this angle to get the other one. So now I'm getting closer. These two angles, 30 plus 85 would be 115 degrees. Okay, so but still not quite enough, so I need to make this angle even bigger. So I could try 35. 35 times 3, and then 5 less than 3 times. So 35 times 3 is 15. 105. 5 less than that would be 100. So this would be 100 degrees. So the sum of these two is getting a lot closer. It's 135 now. So that's getting a little closer to 143, but still not my target. Okay, so I have a ballpark estimate for what these angles should measure. So let's start over and use our algebra techniques. So remember, when we're translating these equations, we really, the very first thing we want to do is to define a variable. So we are going to let x be something. Okay, so let's think about what we want x to be. We have two angles. So we have one angle, and it's 5 less than 3 times the size of another angle. Okay, so I want to let x be the measure of one of those angles. Okay, so one is 5 less than 3 times another angle. So that's probably, the one we're starting with is probably smaller. So let x be the smaller angle. Okay. And then what I can do is, if x is is a smaller angle, then the other angle, equals 5 less than 3 times that. So how can I write 5 less than 3 times another angle? Well, I know how to write 3 times another angle. That would be 3x, because x is my smaller angle. So 3 times it, but 5 less than 3 times it, so it'd be minus 5. I want 5 less than something. So the other angle is 3x minus 5. So the last piece of information I have is that together they have a sum of 143 degrees. So sum means I add. So one angle plus the other angle, 3x minus 5, equals 143 degrees. Okay, so now I'm ready to work on solving this equation. So I've got 1x here plus 3x minus 5 equals 143 degrees. So I want to take these, there's a term here, 1x, there's 3x, and then this term right here is actually a -5 or a subtraction of 5. Okay, so I can put these two x's together. So it would be 1 plus 3 times x instead of 1 times x plus 3 times x. So let's go ahead and write that. So we'll have 4x minus 5 equals 143 degrees. So I just combined those two terms. So now I can start using properties of equality. So my reason for that is just combining terms or simplifying. So now I'm going to use the addition property of equality, and I'm going to add a 5 to both sides here. Add a 5. All right, and when I go to rewrite that, I will have 4x minus 5 plus 5 is just 4x plus 0. So I get 4x is equal to 148. Okay, so now, because remember what I'm working towards is x equals some number over here. So now I'm getting close. I have 4x equals some number. So now I'm going to use the division property of equality, and I'm going to divide both sides by 4. And let me write my result over here. 4 over 4 is 1. So now I have 1x. Let me go back to my purple here so that it's clear what we're doing. So 4x divided by 4 is just x. And 148 divided by 4 is 37. Yes, 3 times 4 is 12, 28, 37 degrees. Okay, so I'm not done yet because I'm asked what are the sizes of each angle. Well, the smaller angle is 37 degrees. I'm going to go ahead and erase here and assume you have the notes. So the smaller angle is 37 degrees. The other angle we said was 3x minus 5. So if I evaluate that expression, I would have 3 times 37 minus 5. And 3 times 37 is 90 plus 21 is 111. So the other angle is 106 degrees. So the measures of my angles measure 106 degrees and 37 degrees. That's my answer. And as a double check on my algebra, I could add them together and see that they equal 143. Okay, so we're going to move on to example 2 now. And example 2 is also a geometric example, so let's look at it. Given a right triangle, find the measures of the angles if one angle is 10 more than 4 times the other angle, and the third angle is the right angle. So I'm going to draw a picture. We've got a right triangle here, and we've got a right angle and 2 other angles. Okay, so let's use our clues. And we know something about triangles too. We know that the angles all add up to 180 degrees. Okay, so we need to figure out what to call our variable. Now, you could try this one by guess and check as well. And if you like using guess and check, I think you should do that and just see what see how it comes out. But looking back at example 1, I think it seems pretty clear that the algebraic way of solving example 1 was a lot more efficient than the guess and check method. Guess and check, we started, I don't know, I probably did 4 guesses and was getting pretty close to the answer, but I still wasn't there yet. So sometimes guess and check is a really great method, and sometimes it's good just to help you understand the problem too. But let's look at this one algebraically. So again, our first step is going to be to define the variable. So let x be what? Well, we've got 2 angles, so it could be either the big one or the small one. It's going to be easier to make it the small one, and I'll show you why. The smaller angle. Okay, so if x is the smaller angle, that would be this one up here. So we'll call that one x. This one's our right angle. And now we just need to know how to represent this angle here. So we're going to use the clue in the problem. One angle is 10 more than 4 times the other angle. Okay, so this last angle here, we'll call it the other angle. The other angle, and I'm going to write an expression for it. It's equal to 10 more than 4 times. Okay, so it is 4 times plus 10. So that's 10 more than 4 times the smaller angle. Okay, so the reason it works to do it this way is because I could do it either way, but the way the sentence is written, it's telling me what to do to the angle. It's saying multiply by 4 and add 10. So that works well. So this angle in here, I don't know if I can write it small enough, but this is our 4x. Erase in here. This is our angle that measures 4x plus 10. So 4x plus 10 on that angle. Okay, so we said we know that the 3 angles of a triangle add up to 180 degrees. So I have them expressed here. I have x plus 4x plus 10 plus 90 degrees equals 180. Okay, so I had 3 angles here. Here's my first angle, my second angle, and my third angle. And the 3 of them together add up to 180. Okay, so I want to write that equation a little bit simpler. So I'm going to combine the things I can combine. I know I can take 90 plus 10 and make it 100. And I also know that if I have a variable, and this is one of the variable, 1 times the variable, and over here I've got 4 times the variable, I add those together and I get 5 times the variable. So 5x plus 100 is equal to 180. Okay, so then all I've done so far is write the equation and write the expression for the sum of the angles more simply. But now I can use my properties of equality. So I'm going to subtract 100 because remember we're always going for this form of the equation, x equals some number. So I can subtract 100 here and then straighten that out. I like to draw this line down so that I keep the sides of my equation straight. Okay, so 5x plus 100 minus 100 is just 5x plus 0. So I've got 5x on the left side, and that equals 180 minus 100, which is 80, on the right side of my equation. So I'm getting closer. So now I have my x term over on the left, right over here, and it's equal to some constant, no variables over here. So I'm getting really close to this format. So now I just need to do use one more property of equality. So I'm going to divide by 5. I'll show it this way. Divide by 5 on both sides of the equation. So that's the property of equality for division. And when I simplify that, I've got 5 over 5, which is 1. So now I know that x is equal to 80 divided by 5, which I can do here. Goes in 16 times. 16 times. So x is equal to 16. Okay, so x is equal to 16. That solves my equation, but it doesn't answer the question, right? Because given a right triangle, find the measures of the angles. So I know that one angle is 16 degrees. The other angle is this expression, 4x plus 10. I'm going to give myself a little bit more room here. Okay, so x equals 16 degrees, and that's the measure of the smaller angle right up here. Remember, always go back to what you'd let x be. So the other angle is 4x plus 10, or 4 times 16 plus 10. 10 more than 4 times the other angle. So 4 times 16 is 40 plus 24 is 64 plus 10, which is equal to 74 degrees. So the angles in this triangle measure 16 degrees, 74 degrees, and 90 degrees. So I should double check to make sure that 16 and 74 add up to 90, and they do, 80, 90. Okay, so there is my solution. Okay, now I could have guessed and checked that, but solving the equation was pretty straightforward also. Okay, now I want to show you another way we could have set up this problem slightly differently. Okay, so we have the same variable defined. X is the smaller angle. 4x plus 10 is the second angle, the next one over here. So here's x, here's 4x plus 10, and here's my 90-degree angle for my right triangle. Okay, so another way I could have thought of this and written the equation is to say that these two angles over here add up to 90 degrees because this one is also 90 degrees. So I could have just said x plus 4x plus 10. Those are the two angles. If I add those together, I get 90. Okay, and then I could solve this equation by saying this is 5x plus 10 is equal to 90. I could have subtracted my 10 from both sides. This would be 5x is equal to 80. And it gives me the same exact result as you might have guessed. Divide by 5, gives me x equals 80 divided by 5, or x equals 16 degrees. And then I could go ahead, so this would be 16. 4 times 16 plus 10 is 4 times 16 plus 10, what was it? Is 74. Sorry, short memory. This one is 74 degrees. Okay, so the only difference here is wrote the equation slightly differently to start, but I got the same result for my variable. Okay, now we're going to look at another example. This one is not in your notes, but you can take notes on a blank sheet. Okay, so example 3. A pair of alternate interior angles are described as follows. One angle is 14 more than half a number. The other angle is 6 less than half that number. Are the angles congruent? Okay, so let's just do a quick review here of alternate interior angles. So if we have two lines and they are cut by a transversal, the alternate interior angles would be here. So they're inside the lines and on opposite sides of the transversal. And remember, we said if the lines are parallel, then the alternate interior angles are going to have the same measure. But if the lines aren't parallel, then they won't have the same measure. So in this case, we don't know if the lines are parallel. We're being asked, are these angles congruent? And we're given a clue. One angle is 14 more than half a number. The other angle is 6 less than half that number. So we can look at these angles and define them by the description given here. So we need to think about what our variable is going to be. In these other problems, our variable was the measure of one of the angles. But this one sounds a little different. We're talking about a number here. These are both defined in terms of a number. And so half a number and half that number. So let's let x be that number. Be the number that's being talked about here. Okay, so x is that number. So let's call our angles angle A and B. So angle A is equal to, we'll let that be the first one. One angle is 14 more than half a number. So half my number would be x divided by 2. 14 more than that would be plus 14. Angle B is similar. It's 6 less than half that number, the same number. So it would be half of the number minus 6. 6 less than half a number. And so here's the measures of my two angles in terms of this variable. And I want to know, are the angles congruent? So this is a little different. So if you're not sure what to do, just bear with me, just follow along, and you'll get it. So I'm going to assume, let's make an assumption. We're going to assume that they are congruent, and then I can solve for x. I'm going to assume that angle A has the same measure as angle B. And I can write this equation because angle A is this expression, angle B is this expression. So I would have this equation, x over 2 plus 14 is equal to x over 2 minus 6 if the two angles are equal. So now to get the x terms all on one side, I'm going to subtract. So I'm going to subtract x over 2 from both sides. So that's what this would look like. Here is I would have x over 2, and then I'm going to subtract x over 2 minus x over 2, and I still have plus 14 is equal to x over 2, and in red, subtract x over 2 minus 6. So I still have that. So when I straighten this out, I've got, let's put some parentheses here so you can see what's going on. I have this x over 2 minus x over 2 on both sides of this equation. So that ends up being 0. So I end up with this equation that says 14 is equal to negative 6, which I know is not true. 14 does not equal negative 6. Therefore, this original equation that I wrote also can't be true because this isn't true. So these angles are not congruent. No, they can't be congruent the way they're defined. They are not congruent. Okay? This is a kind of a tricky way of going about proving this, but there's no way that half a number plus 14 could equal half a number minus 6. Therefore, the angles are not congruent. Okay, kind of an interesting example. All right, now we're going to move on to the exercises that you have in your notes. But first, I want to just summarize what we're learning in this lesson, or what we have learned. We're always learning, though, right? We never totally arrive. At least I haven't. So we know that an algebraic method for solving equations is more efficient than guessing and checking. Usually, I would say. Usually more efficient than guessing and checking. Okay, so that's one thing that we looked at in the first example. We tried it by guess and check, and it was taking us a while. We know how to write and solve equations that relate to angles, triangles, and geometry in general. So we used what we knew about geometry to help us add to the clues that we were given in a problem. And we know that drawing a diagram can sometimes make it easier to understand a problem, especially when it's geometry, and that there is more than one way to solve an equation. So those are some of the things that we're being exposed to here. Okay, now it's your turn to go first. So I'd like you to work on exercises 1 through 6 on your own. We'll do them one at a time as you come back, but see how you can do. So I'd like you to try to set up the equation, define a variable, solve the equation, and answer the question. And if you need hints, then I encourage you to come back and watch the video as we do them together and get some hints, and then maybe pause again and try to do it on your own. Okay? The more you stretch your brain on these, the better you're going to learn it, and the quicker you're going to learn it. So allow yourself to struggle a little and just imagine your brain growing. Okay, so go ahead and pause and then come back and we'll do these together. Okay, so let's read exercise 1. A pair of congruent angles are described as follows. The measure of one angle is 3 more than twice a number, and the other angle's measure is 54.5 less than 3 times the number. Determine the size of the angles. All right, so we need to write an equation. We're going to have an unknown because we're solving for something. So let's let that be x. So we're going to let x be, now I might be thinking, are we going to let it be an angle, or what are we going to do? But we have this number referred to in this sentence, and the measure of one angle is 3 more than twice a number, and the other angle's measure is 54.5 less than 3 times the number. So let's let our number be x right here. So let x be the number. Okay, so we'll let x be the number, and then we can write expressions for the angles that were given. Okay, so we'll call, okay, so one angle is equal to 3 more than twice a number. So twice a number would be 2x, 3 more would be plus 3. Okay, so now we've got another angle. We can write an expression for that one. It's 54.5 less than 3 times the number. So here's 3 times the number, and 54.5 less would be minus 54.5. So now we have an expression for each of the angles, and we have a clue about the angles. We're told that they are congruent. Okay, so since these angles are congruent, their measures will be equal. So I'm going to write an equation here. 2x plus 3 is the measure of one of the angles, and so that should be equal to 3x minus 54.5. So now if I look at the left side and the right side, both sides just have one term with a variable. This side has the 2x, this side has the 3x, and then they both have a constant. So there's nothing really to do to simplify the right side or the left side. So I'm going to start using the properties of equality to solve this equation. Remember, I'm getting it in the form x equals something. And so I'm going to start by subtracting 2x from both sides. I'm going to subtract, I could subtract the 3x, but then it would be negative on one side, and I like to keep things positive when I can. So let's get my equal sign, or the lining up the equal sign. So 2x minus 2x is 0x. 2 minus 2 is 0, so that'd be 0 times x. So we don't have to write it. So this side of the equation, the left side is just 3 now. 2x minus 2x is 0, plus 3 is 3. 3x minus 2x would be 1x, and I can just write that as x alone. And I still have this negative 54.5 that I'm subtracting. Okay, so I'm getting closer. I have no x terms on the left side. So I'm going to use the addition property of equality, and if I add 54.5, add 54.5 to both sides of this equation, then I will have x all by itself on one side, which is what I'm going for. So the negative 54.5 plus 54.5 is 0. So I could go plus 0 there, but I don't really need to because it doesn't change the x at all. Okay, and then on the left side of the equation, I have 57.5. All right, so I've solved for x, and x has a value of 57.5. So now I need to go back to my problem and see what it is. Well, x is the number that's referred to in here, but I'm asked to determine the size of the angles. That's what the problem is asking me to do. So to determine the size of the angles, I'm going to have to evaluate these expressions. So one angle is 2x plus 3. So that would be, with my variable, that would be 2 times 57.5 plus 3. And that would be 2 times 57.5 would be 100 plus 15, 115 plus 3, which is 118. Now my angles are congruent, so they're both 118 degrees. So that is my answer. As a double check to this problem, what I would do is I would now go and evaluate the other expression. So 3x minus 54.5 is the measure of the other angle. So this would be 3 times 57.5 and then minus 54.5. So this should also equal 118 if I've done this correctly. So 3 times 57.5 is 150 plus 22.5. So this would be 172.5 minus 54.5, which is also equal to 118 degrees. So again, the size of the angles is 118 degrees. Okay, let's look at example 2. And again, hopefully you have struggled over this and tried it, and you're just checking your answer here. Okay, so the measure of one angle is described as 12 more than 4 times a number. Okay, so there's a variable here, a number, x. Its supplement is twice as large. Find the measure of each angle. Okay, so let's write an expression. Well, first let's define our variable. Let x be the number mentioned here. Okay, so one angle, let's write an expression for one of the angles. One angle is 12 more than 4 times a number. So that would be 4x plus 12. And then another angle, the supplement, I'm going to abbreviate that, is twice as large. So that would be 2 times the first angle, 4x plus 12. The supplement is twice as large. So let's simplify that expression. That would be 2 times 4x, which is 8x, plus 2 times 12, which is, 24. 2 times 12, 24. Okay, so one angle is 4x plus 12. The other angle is 8x plus 24. And we know that they are supplements. So supplements add to 180 degrees. And so we know that 4x plus 12 plus 8x plus 24 is equal to 180 degrees. All right, and so combining, or let's I've got 4x and 8x, so that gives me 12x. So I know that 12x plus, and I can also combine the terms that don't have the variable, and 12 plus 24 is 36. So 12x plus 36 is equal to 180. Okay, so I have simplified the expression on the left-hand side of the equal sign. And now I'm ready to use properties of equality. So I'm going to use the subtraction property and subtract 36 from each side, keeping this equation balanced. And I'm going to get a new equation here, and it's going to be the positive 36, negative 36 balance cancels out or subtracts to 0, becomes 0 is a better way to say that. So I'm left with 12x on the left side. 180 minus 36 is 144. And now I just need to divide by 12, and I get that x is equal to 12. Okay, so I know x is equal to 12, but that doesn't answer my question. Once again, I need to find the measure of each angle. So the first angle is 4x plus 12. So 4x plus 12, if I put in 12 for x, I'm going to get 4 times 12 plus 12, which is equal to 48 plus 12, or 60. And then my other angle is double that, or 120. So the angles are 60 degrees and 120 degrees. Okay, example 3. A triangle has angles described as follows. The measure of the first angle is 4 more than 7 times a number. The measure of the second angle is 4 less than the first. And the measure of the third angle is twice as large as the first. What is the measure of each angle? So we're going to let our variable x be the number. So we can write expressions for the angles. So the first angle is 4 more than 7 times a number. So it's going to be 7x plus 4. And then the second angle is 4 less than the first angle. So the first angle is 7x plus 4 minus 4, because it's 4 less than the first angle. So that's just going to be 7x. So my first angle is 7x plus 4, my second angle is 7x, and my third angle, my clue is twice as large as the first angle. So it's 2 times 7x plus 4, which is 14x plus 8. Okay, so this is a triangle. So if I add all of these angle measures together, all three expressions, they should equal 180 degrees. So I can start combining terms. So again, let's look for all of our x terms and put those together. and that would be 28x. And then I can get the constant terms here, 4 and 8. So this is 28x plus 12 is equal to 180 degrees. Subtract 12, and what do I get here? 168 there, and this is 28x is equal to 168. I'm running out of room here, but 168 divided by 28, that means x is equal to 6. Dividing both sides by 28. So x is 6. So let's figure out what our angles are. My first angle, if x equals 6, my first angle is 7 times 6 plus 4. Because I'm over here looking at this expression here, 7x plus 4. So 7 times 6 plus 4 is 42 plus 4, or 46 degrees for the first angle. The second angle is just 7x, so it's 7 times 6. It's 42 degrees. And then my last angle is twice the first. It's 14x plus 8, but I also know that it's just double 46, so it's going to be 92. And as a double check, I could check to see that these three angles add up to 180, and they do, 180 degrees right here. So here's the measures of the three angles. Okay, exercise 4. Okay, in exercise 4, one angle measures 9 more than 6 times a number. A sequence of rigid motions maps that angle onto another angle that is described as being 30 less than 9 times the number. What is the measure of the angle? Okay, so one thing we know is that these angles are congruent, right? Because this clue right here, a sequence of rigid motions maps the angle onto another angle. So rigid motions would be for congruent angles. All right, so so our number is x right here. So let x be the number. One angle measures 9 more than 6 times a number, so it's going to be 6x plus 9. 9 more than 6 times a number. The other angle is described as being 30 less than 9 times a number. So 9 times a number minus 30 is the other angle. A sequence of rigid motions maps them onto one another, so they are equal. All right, so I'm going to quickly go through the steps here of solving this equation. This video is getting kind of long, so I want to make this go a little faster here. So what do we have now? 6x minus 6 is 0. I've got 9 is equal to 3x, 9 minus 6, minus 30. Now I can go and get the 30 on the other side. Get this going here. I'm left with 3x over here because the positive 30 that becomes 0 on that side. So this is 39 is equal to 3x. Divide by 3. And I'm going to get that, I'm going to write it over here, that 39 divided by 3 is 13. 3x divided by 3 is just x. So 13 equals x. So what is the measure of the angle? I can put it back into one of these expressions. 6 times 13 plus 9 would be 60 plus 18, 78 plus 9, which would be 87 degrees. Okay, so let's move on to exercise 4. No, exercise 5. We're on now. We're getting there. A right angle is described as having an angle of measure 6 less than -2 times a number. Another angle measure that is 3 less than -1/4 the number, and a right angle. What are the measures of the angles? Okay, so x is going to be our number here that's referred to here. So this right triangle has 3 angles. So the first one is 6 less than -2 times a number. 6 less than -2 times a number. So here's -2 times the number. 6 less than that would be -6. So that's one angle. The other angle is 3 less than -1/4 the number. So -1/4 the number would just be -x/4. And 3 less than that would be -3. Okay, and then the other angle is a right angle. So what are the measures of the angles? Well, so I know that the other two, if I've got a right triangle, the other two angles are going to add up to 90. So let's go ahead and add these two expressions. -2x minus 6 plus -x/4 minus 3. So I've got these two expressions added together should equal 90 degrees. All right, so I'm going to rewrite this expression. I've got -2x plus a -6 plus a -x/4 plus a -3. Everything's negative, okay? And I like to write it with addition signs because I want to move them around. So I'm going to take -2x and I want to add that to -x/4. So we'll do that in just a minute. And then I want to take the two numbers, the -6 and the -3, and add those. So I can do that a little more easily. So this is going to be plus a -9, because those two together would be -9. All right, so now what I want to do is I want to combine this. Now this is all still equal to 90 degrees over here. This was equal to 90 degrees. So now I want to combine those terms there. And to do that, I need a common denominator. So I'm adding fractions, even though they have a variable in them. I can do that. But I want a common, I need to have them both be in fourths. So let's look at what that would look like. I want to take 2x and change it into something over 4. So let's come over here on the side. If I've got 2x, and I want that as something with 4 in the bottom. So I've got 2x over 1. What I'm doing is I'm getting an equivalent fraction. So I want to multiply times 4 over 4, right? I'm like, give myself a little room. I'm going to multiply times 4 over 4, just as if it were just numbers and I'm getting an equivalent fraction. So that's going to be 8x over 4. All right, so that's kind of the idea here. So I'm going to change this negative 2x to, I'm just running out of room, to 8x over 4. So this is going to be negative 8x over 4 plus negative x over 4 plus negative 9 equals 90 degrees. I'm just going to keep going here. So negative, to combine these two fractions, now I have negative 9x over 4. And I'm going to add 9 to both sides of this equation. So that's going to give me, I'll put this in red. So I'm going to go plus 9 and plus 9 at the same time as I'm doing these other changes. Okay, so that cancels out over there. This becomes 0. And so I have negative 9x over 4 equals 99 degrees here. Okay, now I'm going to multiply by the reciprocal of this number. So it's going to be negative 4/9 and multiply this by negative 4/9. And what's going to happen is, I don't have right, I would like to write it below, but I'm going to write it over here. I'm going to get that x, because this over here, this part is going to become 1. Negative 4/9 times negative 9/4. So now I have just 1x over here is going to be equal to whatever this multiplies out to be. And this is looking nicer now. So this is 9 and that's 11. So I've got x is equal to 11 times negative 4, or negative 44. Okay, so I'm going to clear this. We know that x is negative 44. Okay, so x is negative 44. And so my first angle there is 6 less than negative 2. So negative 2 times negative 44 minus 6. So this is negative times a negative is a positive. So I've got 88 minus 6, or 82 degrees. So one angle is 82 degrees. Okay, the measure of the other angle is 3 less than negative 1/4 the number. So negative 1/4 times negative 44. Negative 1/4 the number minus 3. So that would be a negative times a negative is positive. 1/4 of 44 is 11 minus 3, which is 8 degrees. And here's my double check. 82 plus 8 is equal to 90. And that was what we did. We said that those two angles would add up to 90. So the angles are 82 degrees and 8 degrees. All right, that was a fairly complicated example. Don't get too worried. Your problem set doesn't have any that are quite that crazy. Okay, last exercise, exercise 6. One angle is 1 less than 6 times the measure of another angle. The two angles are complementary angles. Find the measure of each angle. So this time we don't have, they're not talking about a number here. So I'm going to be able to let x be the measure of one of the angles. So let's let x be one angle. And one angle is 1 less than 6 times the measure of another. So the other angle will be 1 less than 6 times 6x minus 1. 1 less than 6 times the measure. Okay? So one angle is x, the other is going to be 6x minus 1. The two angles are complementary angles, so find the measure of each angle. So if they're complementary, that means that 6x, well, let's add them together. X plus 6x minus 1 is equal to 90. So 7x minus 1 equals 90. And then if I add 1 to both sides here, then I can see that 7x is equal to 91. And then to get what 1x is, I'm going to divide 91 by 7. And I'm going to come up with x is equal to 13. So 13 degrees is the measure of one of my angles. The other one is going to be 6 times 13 minus 1. And they also have to add up to 90. So 6 times 13 minus 1 is 60. 78 minus 1 is 77 degrees. So 13 degrees and 77 degrees are the measures of my angles. Okay, so I'm going to give 2 days for this lesson. So you've watched the video. I would maybe do the exit ticket today and then the problem set the next day.